They're two industry professionals focusing in the DevSecOps domain, and today they're going to walk us through a comprehensive and practical introduction to securing container images with Sigstore and Cosign. The title of their workshop is Hands-on Container Image Security, Mastering Sigstore for Unbreachable Integrity. Please welcome Mohammed and Sid.
Thank you. Thanks, Mike. Thanks for having us.
Make sure, make sure you stay pretty close to the mic.
Well, good afternoon, good evening, everyone. Thanks for joining us. We are here to present our talk as well as workshop on hands-on container security. For those who we are industry professionals from cloud DevSecOps domain, and we have been in this field for almost a decade. And we are going to talk about a different container security and how we can breach and how we can mitigate the breaches. So, but don't worry, that isn't just another cloud talk. There are zero chance of rain, so we'll try to stay above the fog here. And can you change the slide? Well, who we are. So yeah, I'm a DevSecOps architect, and I'm an author, advisor, and as well as speaker. So I have delivered my talks at a bunch of other conferences, like starting from Boston, Paris, and as well as other places like the KubeCon, Cloud Native CloudCon, and other conferences too. Before we jump in, quick show of hands. How many of you are attending DevCon for the first time? Cool. How many of you are attending DevCon for almost like 5 years? Awesome. For a decade? Oh, cool. Well, alrighty. Let's get started. You wanna go?
Hi, I'm Amir Sayed. Go by Amir. So, you can see a brief introduction here is cloud architect and speaker stuff. So I'm actually mostly focused on supply chain security nowadays. But initially I started as a development engineer and then moved on into cloud and now moving into supply chain. I have also been speaker as well as co-chair on various technical conferences back in India. And yeah, that's a brief about me. We will be going through container security, starting from what is containers. So basically, if you have worked with, sorry? Okay. So, do you want to continue?
No, that's fine.
Okay. So basically, with the containers, if you have worked with any virtual machine, be it VirtualBox or VMware, you have been using some hypervisors there. But in those cases, although those are also reusable and use and throw resources, but in those cases your laptops or system resource is still blocked. So there is another level of hypervisor which has been introduced with virtualization, which is actually containers, where is also a form of operating system. A single container can have one operating system. That operating system will be using anything from microservices to API calls, and those processes will be trigger another software application from it. So this can be a simple user mode call, and sometimes it's also it can also make a kernel mode call, but it depends on what kind of access and privileges provided to those containers. So that's essentially is the basic of container. For example, if you get the names from Dockers to Kubernetes, these are essentially a part of the containers lifecycle. The Dockers are the specifically containers which is used to instantiate or initiate new instances of containers, and you can use container orchestrator like Kubernetes to deploy and also manage that in a scalable format. So that scalability is the key when we talk about Kubernetes. But if we are just looking for having certain individual instance of operating system or systems running there, then we will be just focusing on Docker or related containers. So key features of containers. Key features of containers are, as you understand, it is isolation, lightweight, and consistency. So essentially making it even light mode as it was with the virtual machine, having more focus on having the full instances. But in terms of security, this actually helps to start with the base instance, and then you can initiate that base instance with that base instance, or the base container won't be having anything, and we call those as base images. Those base images can run with bare metal services, and depending on the requirement of the application, we can have ISE codes which can run over whenever it is required. So that's also making it very lightweight, as well as running in isolation, because we will be having those containers running only for the VPC in which it is running, or the network isolation it will be running. So we can have those network isolation in our inside our own operating system. So based on on which port we are running, as well as you can attach it to your host as well as host IP address, and it will be only running on those. So you can actually compartmentalize your external network into internal network to splice the IP address into multiple for running those Docker in your those container in your environment. So that's pretty much is the basic of containers. So there is the case study which we are discussing is very interesting. With Docker Hub is a container registry. When you talk about registry, as in the name register, so what is the register? In previous days, register was used to record something. So you keep the record of whatever you want to use, whatever you want to just postpone for later of time, and those will be there in the registry. So ultimately, Docker Hub is one of the container registry which will be having all the images with its resource details, and so the case study which we are discussing is that how vulnerable are these container registry is. So Docker Hub is one of the open source, although there is a premium version, but you can create your own account for free and use it. With this, it is a very open environment where you can push your images on Docker Hub, and those images, if it is it's make a public, you can have your public you can have it as a public registry as well as a private registry. If it is a public registry, then it's accessible to public. So in 2023, this was a reiteration of another attack which happened in 2016. A researcher actually found 1,000 of images with in the Docker Hub, which actually was providing authenticated keys as well as secrets. So this was due to the misconfiguration of repository. Some of the misconfiguration can be with the rule set in the Docker Hub. You need to have those public registry being signed with those public registry will be storing your images, and those images need to be further having some recognition or some integrity check. If there is no integrity check of those images, then you can have those images just pulled by a Docker pull into your environment, and you can just have some changes on those images and then push it up, because there is just a simple hash check which is not checking for the previous image is been tallied or match or not. So we have to have that further check for image tamper. Only then we can actually proceed to have the safeguard to stop these kind of integrity problems. So as we understand, a CIA is one of the cornerstone is I. So we have to have that integrity of the environment as well. So yeah. So that's we have to cover, and yeah. So these are the common containers which you can choose. So I think we have also covered this, and yeah. So why we are talking about container security? Container security will work just like if you have your own laptop connected to your work Wi-Fi. Although your work Wi-Fi is very much secure, but your laptop, if it is not doesn't have the provider security control, having a weak password, as well as is not using the VPN as well. So in the remote environment we can have those aspects which we have to gain here. The key aspects basically is the image security. In the image security, need to have the base image hygiene or hardening. As I was initially saying, that the container images are built in, need to be built in from trusted source, and those trusted and verified sources can be Docker content trust, or can be any trust repository, or you have to have trust of root of trust established for the image to be stored in the container. So either you will be using a trust store which will be verifying the images which you are pushing, or you will be verifying first and then pushing it, and then again in the pull you will be again verifying it. So it can be either of the points. So similarly, configuration management is one of the keys there. So secret management as well as a secure configuration. Secret management from having the secrets managed on the secret. The secrets can be, so sometimes the misconfiguration which we had in the previous slide, the misconfiguration is mostly due to programmer mistake or not understanding security point of view of sensitive data. So what exactly is sensitive information for that? So maybe they understand that password is a sensitive information, but maybe doesn't understand that GitHub secret or just API key is also a secret. So these secret can be dangling on, or can be put in on a Docker file or on any configuration management file. Sometimes it is also just hard-coded there or provided as an environment file, which can be retrieved if you pull your image, and then from the image you are just when you are pulling the image, when you can find out the orchestrator information out of that, and then based on the lateral movement of various lateral information which you can gain from the images, you can go for a container orchestrator attack, which will be very critical to find these secret. As well as in the previous talk we have seen that there are tools which actually you have to run over the repository, and they will just dump you those secrets. You can also use Trufflehawk, which is another open source. So these are very critical points which you have to look for whenever you are focusing on container security. So that's pretty much it. So the common vulnerabilities of the container environment is insecure container image, and then insufficient isolation, insecure default. So insecure default is mainly the misconfiguration. Insecure container image is mainly targeting or pointing to the image integrity. So we will be focusing on in this workshop basically on that, how the outdated or the vulnerable software content, including the binary, which might be having known security flaws, can be detrimental for the environment. So yeah.
Continuing to it, the common vulnerabilities in containerized environments. So as my friend mentioned, we have different images pulled and compromised. So let's say, for example, that the hardcode secrets are there, and again, we have untrusted container registries and insecure communication. So how are we going to handle this? How many of you are aware of the privilege access management? Well, I got one. So how are we going to handle the secret keys, stored password, hard-coded passwords, and let's say, for example, SSH keys? So in that fashion, if I like dwell towards the common vulnerabilities, there we can have those stored in the environment and then retrieve from the environment whenever needed. So let's say the HashiCorp vault, we have an APIs, correct? So we can retrieve using those APIs, we can store them, and we can implement a monitoring tool which can direct and redirect the suspicious activities and potential attacks, what's going on. And when coming to the insecure communication thing, so probably we can have strict EDR tools where we can have any sort of attacks going on, any sort of errors or any sort of flaws coming in, so that can alert your environment and an admin control. So that's something you can have leverage, and you can take proactive steps before you head the production or development stage. Now, the privilege escalation thing, the most important thing where we can exploit and gain control and access to it. So a use case where development team pulls a popular image based from a public repository, and as well as the microservices. So if at all, if you have OpenSSL and vulnerabilities included, so attackers can exploit it and intercept and decrypt the sensitive information too. So the company uses an outdated sort of Docker, let's take an example, Docker Swarm with known vulnerabilities. So how the attackers can exploit these vulnerabilities and take a control and orchestrator disrupting and deploying the malicious containers, and then also which can also control the plain very permissive and excessive controls. So from an insider perspective, there are basic exploits as well as privilege exploits for the misconfiguration things, so with deeply unauthorized containers and leading to the breaches. And then coming to the mitigation strategies, as you can see, we have a bunch of a couple of listed out here. So besides this, I'm going to talk what's not in the PPT deck. So for example, let's say you have a base image from the considered trusted source, like an official repository. So let's say you have to scan an image regularly, scanning of image that keeps you away from vulnerabilities, and as well as tools like Trivy and Clade and another Anchor tools where you can minimize the attack surface. So next, coming to the other mitigation strategies are use minimal base images like Alpine to reduce the number of potential vulnerabilities, and also you can exclude unnecessary packages and tools from your image instead of having all those deployed in an environment. And then you can implement least privilege role-based access controls too. Most of the things, the secret management where you can store sensitive data, and as well as the a data where you can have passwords, API keys, and as well as the certificate for the Kubernetes secrets. You can have this environmental variables stored in a hard-coded secrets code or a configuration files too, and as I mentioned, you can store in a vault or any sort of dedicated vaulting system technologies. Then coming to the service mesh, so using a service mesh there is a secure, authenticated, and encrypted service mesh we have in the Docker Hub. So you can leverage that and have regular scanning and regular checks across your Docker images too. Now, implementing the runtime security, so that's a different thing where you can have Sysdig as well as the Aqua security to monitor it. If container activities are going beyond the threshold or capacity what you have set, then you can implement the vertical scaling as the horizontal scaling too, where you can scale up the resources vertically based on the CPU, memory, and as well as the storage limitations, whatever you have set according to the production needs. And the last thing is securely having the CI/CD pipelines. This is another thing we can manage using the tools like Jenkins, GitLab CI, Circle CI, or Chef. So with proper access controls, everything can be managed. And for the image signing standpoint, use image signing tools like Notary or Cosign to verify the image signing refactories. Yeah, the other thing, as you can see, there is a YAML script over there. So the Kubernetes pod, what we have we are enforcing here with an isolation policy to enforce isolation. So once you define a pod security policy on this step 4, if you see, I have restricted it to name, and then I'm using a privilege, allow privilege escalation to false, and this is how, like, you can mitigate other sort of strategies too. And then next, for the insecure defaults, you can declare the API server settings, where you can see name is secure API. This is, like, a common, like a friendly name I have given it there. And then you can declare what arguments you are going to declare in that under the arguments variable, and then you can have that particular pod restricted to role-based access controls, whatever you have defined in the rbac.yaml file, and then same thing you can restrict by using TLS cert as well as a private key too. So based on TLS cert and the private key, you can restrict the configuration of the Kubernetes APIs and as well as Docker images too. Coming to the RBAC, so how we can implement RBAC, role-based access controls. So if you see, I have declared the verbs, and under the rules, you see get, watch list. It's kind of a create, update, read, and delete format. So I have used a get, watch, and list friendly parameters, so we can, like, have the access restricted, and we can have a least privilege escalation, least privilege access to the users, and then we can manage the improper access controls. And what are the best practices? So let's say, like, use of minimal image space and also resource quotas and limits. For example, let's say set your CPU and memory limits to prevent resource exhaustion attacks. And then we can also have the quota management, like use Kubernetes and as well as resource quota to limit the number of resources. But we have an environment and data anomalies, and also regularly updating and patching the base images and application dependencies. Yeah, here are the few quick action items we are focusing on. Like, let's say you can review Docker repositories for the misconfigurations on at least quarterly basis or periodically, whatever you have. And then you can implement image management patches, where you can have an authenticated images, kind of, let's say, for example, PDF. You have password protected PDFs too. In a similar fashion, you can have them, like, the password protected as well, implement similar incidents here in the images too. And the last thing, you can conduct regular security audits. Logs is all something, like, we can go after, and we can mitigate the resources, and as well as, for example, let's say Splunk. We have many other tools. Splunk is just an example. What is image integrity? So image integrity is something like, where we have accuracy, consistency of data, and as well as in the context of cybersecurity and digital forensics, it involves ensuring that an image, such as a digital video disc or a photo, has not been altered or tampered, and its creation and the data is not lost, and it's verified until it's stored. So hashing is another technique where you can have an image integrity, where one common method to verify image integrity through hashing is by generating a unique string of characters, and then by comparing the hash current file with the hash of the original file, like MD5, some kind of stuff. And then we can have the digital signatures too, where you can provide a way to verify the authenticity and integrity of an image. And then metadata of an image is something where you can have transparency, as well as, like, provide information about the images and modification of history. So this image can be signed with a private key, and as well as anyone using the corresponding public key to verify that image too. And integrity check tools. Coming to the tools, with the specialized tools in the market, so I don't have any specific tool to go after, but then you can use whatever tool you want to. And the software that can help monitor the image integrity file is corruption unauthorized changes files, where you can have another issues arising with handling the integrity checking tools. So here are the few examples, like use cases for the image integrity. Let's say you have an automobile industry where you need to protect the firmware updates. Well, let's say we have a bunch of other organizations like Tesla. So it completely runs on NVIDIA chips and all, so the firmware. So when you push a firmware update, it has vehicle control ECUs and as well as over-the-air updates. So you need to validate the integrity foam images with the DevSecOps practices and applying updates regularly that can help you secure your images. And then in the food industry, we have securing the recipes and ingredient data. For example, let's say a KFC or a McDonald's. So we don't know the recipe of KFC yet, right? So the similar way, so how are they trying to manage their data efficiently inside the database? So we need to have CI/CD pipelines and a manufacturing software which can prevent the unauthorized data leaking out of their company. In the supply chain container industry firm, there is another thing where we need to focus on, where we have materials and loads of capacities coming in and out, day in, day out. So how are you handling those data? And then how are you taking the container, making a digital records of everything, and making sure the containers are not compromised as long as there is a flow of data. So we have a digital watermarking, and the cryptographic hashing is another important technique where you can prevent the supply chain security, supply chain container industry. You wanna go? Yep.
बदल दो मेरा बीच में वो कर देना राइट खोल देना लगा दी yeah so with the image integrity we understand that the importance of image integrity. Sigstore is an organization which is an open source project, and they have provided a couple of tools which helps or focus on improvement of securing these software supply chain, and these tools essentially helps the same problems which we had in the image integrity, that how to actually check and as well as monitor, verify the integrity of image file, whether the image has been tampered or changed or compromised in the flow of the thing, so in the supply chain. So the basic purpose is to enable security with trustworthiness and making it robust by verifying authenticity and integrity of the software artifacts, be it coming from be it from GitHub as well as any other so we have actually this also enables to build a transparent, increase the transparency. So in case of the transparency, we talked about public transparency log is provided by Sigstore, which employ a public ledger, and this ledger is known as Rekor. So Rekor is recording all the signed software artifacts, using which you can actually make incident response as well as using which you can actually make the response as well as make the required service. चेंज क्यों कर दिया? वही था ना, पिछला था चेंज हो गया। ठीक है, तो खाना वाला लगा दे उधर दूसरे में so so for increasing transparency, the transparency log of Rekor provides it, and for simplifying it also simplifies integration, because it essentially provides the repos in terms of images which you can pull and deploy on your own environment, and all the signing activities are logged in one way or another, which allows for better image review as well as auditing. And so The transparency helps in verifying the history and image integrity of the software artifacts. So this also helps into tracing back the discrepancy or issue which might be having on multiple commits or multiple change of the images version. So this essentially promotes essentially also help in the compliance and regulations, be it NIST 800 218 or CRA, which is more close to automobile and field industry, where with current CRA regulation coming in force from 2027, is required to have all the images or all the images, be it on device, be it your firmware images, having a digital trust. So for those digital trusts, you have to work for transparency and auditable logs, where you can actually go forward and check if there is any malicious activity resulting into some uncompromised pipeline issue. So the first tool is Cosign. So Cosign is a tool of signing and verifying container image. So essentially, you can just look onto the diagram. It's taking one example from Docker Hub. So if your image, the base image or the Alpine image is in Docker Hub, it can be pulled and then the image pulled in your it can be put into your own laptop or in your own system, can be modified and then onto a registry. In this case, we are taking another registry, that is ECR, because we are pulling from a Docker Hub registry and pushing the image into a ECR environment, which is also a container registry in AWS. In GCP, it will be GCR. So we are just transferring it into GCR or ECR. In this case, as you can understand, the environment of AWS or any cloud vendor will scanning or some vulnerability scan, but those vulnerability scan doesn't interestingly cover container images, and they are just looking for the related code-based scan, as well as if the image is been flagged somewhere or the image signature has been flagged in the malicious directory, then only the scan result will show something. If you have just changed the image and that image application which you have changed has some echo file or some malicious line added to that, those won't be changed, those won't be checked on ECR image or when you are pushing it on ECR by default. So what Cosign does is, it's actually before pushing into ECR image, it actually sign the image and push it into the ECR. Now you are not pushing any image, you are just pushing the signed image, and that signed image, whenever it has been pulled out of the ECR directory, will be again verified with a Cosign verify function, and if it is passing the match of the signature, it's essentially a type of signature which Cosign directly matches from the previous signed image to the verify image. If it is matching, then you will be able to push the signed image into your ECR directory, or else it will flag that image for the review. So that's end of our first section, and now we will be moving on to our first lab. So for the lab, how many have you read the prerequisite before this lab or this workshop? Okay, no problem. So there are two different ways of conducting this lab. Is first we can do the same thing with Docker Hub, and second we can do the same Cosign image demo with GCR. So does anyone have any GCP account as of now, or anyone has created a Docker Hub account? If not, I would recommend that you can create it, so that after the demo you can run it on your own. We have a walkthrough of these labs, so you can run it on your own. We can come to you, and if you have some problem, you can just check that out. So now we can just close this. Okay, it's not changing. Yeah. So if you are seeing this command, these are actually the 5 base command. The first command is docker tag, which will be essentially tagging the source image into the destination and then pushing it. Then cosign generate key is generating the private key and the public key pair, and sign for cosign we will be using the private key, and for verify the public key should be available. So the asymmetric cryptography mechanism is being just been employed for the destination who is verifying the image need to have the public key, and that will be sufficient to verify the image. So what I have done is I have just spun up a virtual machine, which this is GCP, Google Cloud. So why Google Cloud, why not AWS? Because Google Cloud provides a $300 initiation amount, which we can easily create your free account and get $300, which is not the same case with AWS. You have to pay from the first day. So that's one of the main reason I recommend any new beginner in cloud to start with GCP, because although there are some drawbacks in later stage, but for beginners it's very convenient to start from here. So I've just spun up a compute machine, which is actually equivalent to a virtual machine, and it's very easy. You can just click and it will just next, and you will have this instance. So I'm just going into the SSH of this image. You can also go to the instance or the virtual machine through Activate Cloud Shell as well. So it's the same thing, but I'm just transferring to the SSH key. So what it does is that it just establish your SSH key connection from your Google account, and your Google account is holding the SSH key, not your laptop. So you can connect from anywhere.
Maximize the screen.
Okay. So yeah. Containers. So I have it. Okay, I can start again. So is there anyone who have their own machine spun up or anything where they will like to have the walkthrough tested on their own machine? In that case, I will go slow, or I can just go faster if you are just listening.
Yes,
okay. Sure, no problem.
Go for it.
Okay. So the first step is actually Docker login, which is essentially the login of your Docker Hub. So there can be two. No. Yeah. So So in this stage, you can either, so I'm just following the same flowchart which we have discussed, but it's not always the case. You can have your initial image created at your own laptop or own virtual machine, and then push into the registry. So I'm actually following the same flowchart which we have discussed. So yeah, if anyone want to just see the login, they can go ahead and check the same login. It's actually a just use case for this lab. It doesn't have anything else. Oh, so yeah, this is a common mistake which everyone does. It's you have to have sudo with Docker, because Docker is a high privilege command. It's required sudo every time, but even though you commit the same mistake every time. So then the second step is I'm first going for the I'm going for the Google Cloud credential helper creation. This is essentially authenticating your Google Cloud with your existing instance. So that command is gcloud auth config docker. Yeah, it's working there. Yeah, so this is so you can see that this has essentially run the CRUD helper, which finds all the stage of integration with the Google Cloud and open up the gcloud shell in my own shell. So I have opened shell into shell in that sense. So next step is to create a artifactory repository, artifact registry repository. So for the Docker image, for which you can run it with artifacts repositories create. Oh, I missed yeah, there is another step there. I have to first enable the Google Cloud with gcloud. Enable the Google Cloud project for accessing or for the permission of artifact registry. For that, it is G service or gcloud services.
Enable artifact.
Yeah, enable artifactory registries. So there is another requirement of a token set there. Yeah, token कहाँ रखा है मैंने? वो Docker रखा.
Is it over here?
Yeah, it's actually in the first one, पहले में.
Yeah. Is this the one?
ये एक और था क्या? Yeah, this one. Yeah, this one. Okay, so
Where is it?
random, just start from the start. Okay, so yeah, I think we can skip this one. So we can just nano. Let me make directory for demo 1, cd demo 1. So nano docker file, and yeah. So what I'm doing is creating a वो वाला किधर गया? Doesn't matter. Okay, we will come back to that. Yeah. So okay, I can just create it again. Let me see that notes. Oh yeah, okay, they still have. No problem. Sure. No problem here. Yeah, workshop. Yes, there is workshop, man. Yeah, please shove. Okay. I'm just looking for the Docker Hub key there, which I've kept somewhere. Yeah. Notes. No, not this one. Okay, I can do one thing, just get it again. Account setting and security. Yeah, so this is the PAT token. I have to create a new one again. Get out of here. Great. Yep. So as you can see, it does give the information how to log in as well as the PAT information. So previously I used my password, but with the password you have a less privileged access. So now I will be using my PAT. Copy. Yeah, that's it. So now we can just start setting up the environment. I think we can just go ahead from this one to ls cd container. Yeah, ls cd. Yeah. File. Yeah. So we have just a base image of engine which will be used for creation of the image, and let's see from here then. Yeah. So that's the main file. You can see that there is a hard coding of user as well as password. This is the hard code of the Docker Hub, and essentially this will be enabling the Docker image which we have in the Docker Hub to pull the Docker image. Okay, so that's the line. So it will just pull the Docker image which I have pushed on the Docker Hub and then run it in the environment itself. So what it will do is this GitHub action will actually run it and will update it. So once I actually go into my environment and git clone this directory or this PAT token कहाँ रखा है मैंने? Yeah.
Where did you keep like that?
Okay. The PAT token.
Let me check.
GitHub's PAT token. Oh, 1 minute. Yeah.
Did you find? I think you put it under the. Okay, it's on the machine. On the machine itself.
Let me download it again.
Okay.
Yeah. Let me try this. let me do this. To ask this. Okay, yeah, now I understand. So okay, I actually yeah, so first is yeah, so okay, yeah. So I was trying to git clone a private directory. I forgot that I have not kept it public. So yeah, that's why it was asking for the so if you are trying to clone a private directory, it will ask for the whole login ID. So now it is changed. Skip it. Yeah. So yeah. So you can see there are this git directory is actually created by the action, created for the GitHub action run, and whenever GitHub action runs, it checks for the .github directory for the main or the any YAML you are running. You can give any other name, ci.yaml name as well. So what exactly it has is this. Okay, YAML. Okay, so main file कहाँ गया? Okay, so let me just do this one sh. What exactly is happening here? Oh, okay, yeah. So what I'm going to do further is, so I was not able to open the main YAML file because I'm trying to clone and then try to open a non-writable file. So it is the same file which we already saw on the GitHub. What I will be doing further is adding a echo any comments. In this case I have added XSS function or XSS script. This will be added into read file, and then so I can just so that will be just your readme file on my local repository will be having this command, and then then the next step is to build Docker and push the whole repository which has been created into the original GitHub registry. So you can see that I have given the variables as well as branch and stuffs in this function as well. So it is just updating the file, and the username and the git username config can be given with git config global. This will be having the username as well as passwords for this one. So I have already given the path file in this one. So this will be automatically taking the path from the environment variable, which is not visible here. So because that's stored somewhere else. So we can either run it directly or so let's do it just like this. New connection, connect. let's see. Yeah, so I will be yeah, let me show that. So just to show that the steps there, I will just run these two commands to show how those works. Oh, I forgot one else. Yeah. So then, yeah. So it has just pushed the modified file into the repository. If it will be just push difference of your repository, not the whole one. So not every file will be writable. Only the change which we have made from the clone, it will be only pushing that. So second, yeah, build, then yeah, push sudo. Yeah. So something has changed there. Oh, okay. Pat is not running. Maybe yeah, maybe I have changed it. Something I don't remember.
Let me retrieve your file.
Yeah.
Do you want me to retrieve it?
Yeah, you can.
On the GitHub?
Yeah, it is on the GitHub.
Both.
So okay.
कोई नहीं.
Yeah. ठीक है. Okay. So what? So I can just give the output there, that what exactly it will do. Where is the GitHub? Where is the GitHub file? Yeah, repository version. This one. Yeah. Okay. I'm there. I'm there only. Yeah, so it will just push and do this. So right now some pat issue is there, but that's the main thing with all. That's always the thing with any demo, which you might miss something, and that it might not run at the time when it should. So yeah, it will just do this change. So essentially you can see that based on this GitHub repository, able to pull and push my own change, just because there was no verification at the side of GitHub. There is one check. If why I have used README file, not an HTML file, because GitHub by default uses a GitHub checks some vulnerable extension files. So MD is not one of the vulnerable extension file by them, but HTML is. So if I try to push something vulnerable into HTML, it will block that. So that's there. Yeah. Cosign. नहीं कि cosign का कर सकते हैं. Okay. Okay. So yeah, that's the first lab, and we will provide the walkthrough with the command as well as the syntax, so you can actually use it later on. I think we are nearly getting out of time. So this first one is with Cosign, and second, you can see the outputs here, which I was trying to run. That the basic output will be after the push of that malicious image. For securing those images, I have to just run the sudo cosign sign on that vulnerable image, and then I have to provide a password for the private key. It can be anything, just defcon, and then if I try to verify it, if it is a legit, the original image which has been signed, in this case it is the legit base, then it will verify with these information that the certificate has been verified with the Folicio root. Folicio root is the certificate authority, and signature has been verified for the public key. If I try the same thing with another image which is malicious, it won't able to find the matching signature and will fail. So the same thing can be done with GCR. The pipeline which we are trying to do is we can generate the key pair and sign the ECR. Only thing which we have to do is provide the ECR path of the image which is already loaded in the ECR, and then we can verify it for the ECR registry images as well. So the previous one for the Docker Hub, this is for the image which has been pulled from the Docker and pushed into the ECR. The next one is Folicio. Folicio is a certificate authority, which is by a separate certificate authority. So certificate authority are usually turned over for a longer range of time or longer period of time. But if you require a short certificate, your own private certificate can be created using Folicio. This is completely free or completely open source, and this eliminates the requirement of the long-term private key to be stored in a secret manager, which need to be done in a public certificate authority, and also you have to pay for those requirements there. But the only thing is that for the identity management, this uses OpenID and also eliminate the requirement of the private key as well. So we can side by side use Folicio with a Cosign, where Cosign will be generating the signature, and as the certificate authority of this Folicio has the certificate created the certificate for you. Now you can just make the keyless signature. In previous case, as you can see, we were providing the public key. We were providing the public key to the Cosign. In this case, in case of Folicio, you don't have to provide the you don't have to do the same thing, as the OIDC authentication will be the additional step, and then you will be running the Cosign with the Folicio URL, which essentially will provide the certificate to your image, and then the OIDC authority or the issuer will authenticate the user for the account, and then it will use the private key file there. This private key file is actually not the same. So this private key file will be used for signing the image there, and for verification we will be having the public key file for the image tag. Yeah. So the third and last important tool which Sigstore provides is Rekor. So it actually is a transparency log for storing the metadata of sign artifacts. So in our case, the whole process which we have done, those will be logged into Rekor, that this account or this user has created the public and private key pairs, and which account has signed and which account actually has verified with the timestamp. So those information is being stored in Rekor, and the entries of this Rekor, the entries of this Rekor log or Rekor ledger will be immutable. It cannot be changed once it has been but once it has been done. So it is an immutable ledger. So the basic steps of installation, again the third walkthrough will be provided with all this. We are just discussing how it will be installed. For installation of Rekor CLI, you can just install this Rekor CLI with the Go function, and then it will be signing and uploading the entry into the Rekor server, and the server setup requires a MongoDB as well as a Trillion, and on Trillion server Rekor CLI will be mounted, and the MongoDB or any actually you can use any DB server for storing these entries into them. So Then you can install it on, so you can just install it and then start verifying the images, verifying the entries on the server itself. So this can be also locally set up with your own Docker containers of MongoDB or any other DB, as well as Trillion. There is Docker Hub image of Trillion server, which can be also used for testing purposes. I wouldn't recommend for the production, but for testing purpose it can be used. So that's the flowchart of this validation of the whole pipeline from Cosign to Rekor will happen. The developer or the user will validate the image. The image is actually Oracle CI, so I have actually taken this from another blog which you can use there for your own references. So the OCI is Oracle image, and it will then use the Cosign for signing the image, and then the manifest file will be returning, because we have used with the change on in the change in Policio. We have seen that we are attaching the Policio URL with which we will be attaining a signature. That signature will be further SSH or further provided with OpenSSL to the certificate authority, that is OIDC issuer, that will actually verify Cosign, and which will return the image verification information. That information will be logged into Rekor. So the simple change of the previous cycle to this one is the two things, like this one, this URL as well as certificate, which has been attached from the previous time, where we are actually providing the certificate, not the keys, into the Cosign. So yeah, that's pretty much it from my side. Yeah.
You wanna go? Yeah. So we know, like, we tried to have a lab. Then most of you guys didn't go to the prerequisite, but that's fine. The best practices for GCR, it's already there. I will talk what's not on the slide. So we have sort of how we can handle vulnerability scanning and hard-coded passwords. As you have seen, when we showed you the Git repository, we have hard-coded the credentials over there. So by having those things hard-coded, there are chances of getting compromised. So that's the reason why we have personal access tokens, where we can store in the vault and then retrieve from the vault. In the similar fashion, you can store the credentials in the vault and then retrieve the credentials from the vault, having connection in and out of the vault. So for that connection, you can also have an API. You can also have like any sort of third-party tool installed on your local machine or a VM, and then you can read the secrets from out of the vault. So that's just an example. So as I'm taking an example here, HashiCorp, you can use any sort of vaulting technologies. There are a bunch in the market. So that satisfies the vulnerability scanning and the binary authorization part. So when the build fails to deploy on the server, what are you guys going to do? It's something like, there should be something like, for example, you have a bunch of services running on the production environment, but if you hit a snag, then how are you going to recover it? Let's take an example, the recent CrowdStrike thing. Upgrade, we experience, like, all the Windows users experience BSOD, right? In a similar way, to overcome this, we need to have assigned images where you can eliminate the vulnerability and as well as the compromising of the images in the Docker Hub and repository and in the Git repositories. And the most important thing, we as a security engineers, we fail to rotate the keys, right? So the reason why I brought it up, the vault, because vault has something that it can rotate the keys periodically. You can have the policies declared, let's say 30-day policy, or it's like 90-day policy rotation, or 60-day, whatever you want to, based upon the requirement. So as you keep rotating those policies periodically, you can, you can eliminate the compromising of credentials, keys, or sensitive information in the Docker Hub. So yeah, so that's all for the GCR standpoint. Yeah, thanks for joining this workshop. I would love to walk you through, guys, if you have any sort of VM. I'm happy, I'm here for another hour. I'm happy to hang around, help you guys with spinning of the workshop and helping through executing the workshop too. So beside this, here is our email address and as well as the Twitter account. We will be dropping us the notes, Cloud Village folks. If you can retrieve from them. If not, you can email us and we can share the handouts as well. And that's something we rant the free time we rant around on a podcast, Cyber GPT Plus podcast. Me and my buddy Amir. So we just talk about DevSecOps, emerging threats, emerging cybersecurity practices, and we make audience security awareness, and then make sure they are secure and they are protected digital assets too. Thanks all.